In this video, if you guys haven't watched my calculus video number 14, the title was More Examples, Limits of Trigonometric Functions. Then at the end of that video, I gave you guys some homework, and it was day 6 homework. And I told you guys to pause the video and do that homework, all the questions. And then I'm giving you a solution for these questions right now. So if you haven't done it, do that video first, solve the problems yourself first, and then come back and watch this video. Okay, let's start. Limit questions, since we are doing trigonometric functions. Again, the rule is the steps are going to be the same for solving limit questions. Substitute x value first. If you get 0 over 0, then we need more work. What is more work means? Factoring, least common denominator, distribution, expanding. Expanding like means distribute or maybe FOIL. Split the fractions if one term denominator. Conjugate for square roots. For trig, use identity or rewrite the question. Since we are doing identity, we are doing trig, then we have to use the identity if we need more work, or we rewrite the question. If you get number over 0, then we already know our answer will be positive, negative, infinity, or does not exist. To get the answer, we pick arbitrarily closed numbers from the left and right and find left-sided limit and right-sided limit by plugging in that arbitrarily closed numbers. We are interested in signs, not numbers. If we have negative over negative, we get positive infinity. If we get negative over positive, then we get negative infinity. So something like that. Here we go. Let's start with this question. This is day 6 homework, and I'm using my steps. For the limit questions, we already know, first thing first, we have to make sure that we plug in the pi over 2 like a direct substitution. If we get 0 over 0, then we need more work. Okay, let's plug in that pi over 2 in the question. So I'm going to plug in pi over 2. It's going to give me, and you guys, if you guys remember, cosine square theta means that square, when the square is on the trig, then it means you're going to rewrite this like cosine theta whole squared. That's what it means. So I'm going to plug in, I'm using this. Okay, let me rewrite it, because you have to rewrite always the trig function like this. If this 2 is on top of the trig, make sure everything is inside the square. And then I have 1 minus sine theta. This one doesn't need to rewrite. Okay, let's plug in the pi over 2. So I'm going to plug in cosine pi over 2 whole squared. And I got 1 minus sine pi over 2. Sine 1 minus sine pi over 2. Now let's go back to our trig, unit circle, and see what is cosine pi over 2. So this is my pi over 2 right here. This is my pi over 2. Cosine is a x value, which means it's 0. So, and what is sine pi over 2? It's 1. Okay, so I'm going to go back to my question and plug in the values. Cosine pi over 2 was 0 squared. That one is 1 minus 1. So it means I am getting 0 over 0. And on the free response questions, you have to show them this, okay? So after I get 0 over 0, then it means I need more work. More work means factoring, least common, distribution, expanding, split the fraction if one term denominator, conjugate for square roots. For trig, use identity or rewrite the question. So I already rewrote the question, but I have to write to see what identity. And when I see the square, right, on the cosine or sine, I just quickly remember my Pythagorean identity, which was sine square theta plus cosine square theta equal 1. That was one of my identity. So cosine square theta, since we have a cosine square theta, I can subtract sine square theta both sides. This is cancel, and I got cosine square theta. So cosine square theta is equal 1 minus sine square theta. So it will also, the bottom is also 1 minus sine theta. So I think we will be okay. So let's try that one. Limit theta approaches pi over 2, 1 minus sine square theta over 1 minus sine theta. Now, you guys do understand sine square theta, 1 minus sine square theta means I have two of those. So I can expand, we can expand that now. I have 1 minus sine theta, and I have 1 minus sine theta. 1 plus sine theta and 1 minus sine theta, because the negative means, and you know sine square means the whole thing is in the square, in the parentheses. 1 positive, 1 negative, and the bottom 1 minus sine theta. So they cancel out, and I'm left with limit theta approaches pi over 2. So what is sine? Now I'm going to go back and plug in my my pi over 2. So 1 plus sine theta is what I'm left with, equal 1 plus sine pi over 2. Pi over 2, we already know pi over 2 sine was 1. So it's going to give me 1 plus 1, which is 2. The answer is 2. Okay, let's do this question. Now, again, plug in 0. So I'm going to plug in, do the direct substitution, plug in 0 plus sine 0 over 0. What is sine 0? So if you guys pay attention, this is my 0 right here. This is my 0. Sine means a y value, and it's 0. So technically I got 0 over 0 again, which means I need more work, and it's a trig function. You know, I can rewrite this. I cannot use any identity, I think, or we'll think about it. Since I have a single denominator, right? One term denominator, I can split. So the splitting is really, really good. It makes the question easy. So make sure that you do that if you have single denominator. Sine x over x. We do have an identity kind of thing over here. If you guys remember, that was one of the special trig functions. If you have sine x, like the argument and the denominator are exactly the same, and you are approaching, for example, x in this case approaches 0, it has to approach 0, then this means my answer is 1. And I had another 1 minus cosine x over x, and this is the same thing, limit x approaches 0. Then this one was equal 0. So you guys remember these identities over here. So sine x, and since it's approaching 0, I know it's going to be 1. And they cancel out, so I got 1 plus 1 will give me 2. See, if you rewrite the question, you split, you pay attention, and you memorize these steps, it will make it easier. Okay, let's do question number 3. Now, 3 is a piecewise function, right? Limit x approaches 3, 2x squared minus 3x in 8 minus cosine pi x over 3, and the restrictions are less than 3, and this x is greater than 3. And I'm approaching 3, which means if I have a piecewise function and they give me x approaches left and right to 3, then I have to give them left and right limits. So I'm going to go and I'm going to plug in limit x approaches 3 from the left. So left is this one, because x less means left, okay? Less means left. So I'm using this one, 2x squared minus 3x. Now plug in that 3, 3 squared minus 3. This is going to give me 3 times 3 is 9. 9 times 2 is 18. 18 subtract 9 is going to give me 9. Okay, let's do limit x approaches 3 from the right. Make sure when you have a restrictions like less and greater and you have a piecewise function, you have to do left and right unless they mention here. Like in this case, they don't have any positive or negative appear on top of this 3. So which means I have to do both. If they give me like, okay, just do positive, like just from the right side, then I will do just the right. And I will just use this piece of the information. Okay, from the right, I'm using that information, 8 minus cosine pi x over 3. Okay, so if I plug in 3 here, I know 3 cancel out, I'm left with pi, right? So now I'm getting 8 cosine pi. This is pi, cosine is -1. So minus -1 is going to give me 8 plus 1, which is 9. Do you see the left side limit and the right side limits are exactly the same, which means the limit exists at x approaches 3 for this piecewise function. So we're going to write the final answer, limit x approaches 3, 2x squared minus 3x, comma, x less 3, 8 minus cosine pi x over 3, and this one x is greater than 3. The answer is 9. Okay, let's do question number 4. I have, and again I'm going to do the direct substitution first. Sine, I'm going to do direct substitution. 2 sine 3 pi is going to be 0, so that's sine 0 over 0. So sine 0 is 0, so that's going to give me 0 over 0. Okay, so now let's do what we can do here. Should I rewrite the question? I have a single like a one-term denominator, and or I should use identity. If you guys pay attention, I have sine 3 theta, right? Sine 3 theta. If I can separate this, you know, when I have the argument and the denominator exactly the same and it's approaching, limit approaches 0, then it means this whole thing's supposed to be equal 1, like the one I gave you up here, right there. But I have to make sure that I can take care of this too, and also have a 3 in the denominator, so the argument and the denominator look exactly the same. So for this purpose, I'm going to move this 2 to the front like this. I just want to move it so I can have something that I can change around. This is what I got. Now I'm going to use a different color, and if you guys see, if I multiply 3 here and if I multiply 3 here, top and bottom, so look at this, sine 3 theta over 3 theta, same argument, this is argument, right? Same argument and same denominator, so this whole thing is equal 1. That 2 is going to stay as a 2 times this whole thing, like limit approaches 0, theta approaches 0, and this whole thing is going to give me 3 times 1, so that's going to give me 6. So it's kind of easy once you do the practice, you will see it's gonna go really good. So I'm gonna move this, the unit circle, because we're gonna need it down there, and I don't want to go. Okay, the steps we already remember those. Okay, let's see. Now question number 5, limit x approaches 0, sine x over 2x squared minus x. What can we do here? First thing first, direct substitution. I got sine 0 over 2 times 0 squared minus 0. So I know the bottom term 0, everything. Sine 0, we already know sine 0 was 0, so 0 over 0. Now what should I do? Should I rewrite factor, or should I be doing anything over here? Sine x on the top, I can't do anything with that one. But if you guys see in the bottom, I can factor out the x. I can rewrite the question. Limit x approaches 0, sine x. I mean, you can't do anything with sine x. This is just one term. So x common factor, I got 2x minus 1. What else I can do here? Do you see this one look familiar? Sine x over x. If I can separate and rewrite this, let me rewrite this and see if we can do that. So approach is 0, sine x over x. You see, this thing is familiar. Same argument, same denominator, which is equal 1, and I am approaching 0. I always check, well, if I'm approaching 0, because this property doesn't work. This special trick doesn't work if you're approaching other than 0, like if you're approaching something else. Times 1 over 2x minus 1. Do you see? I rewrote the question. This whole thing and this, the separated one, are exactly the same. So what I'm going to do, you know, limit x approaches 0, sine x over x. This whole thing is equal 1. I know that. Times, I'm going to plug in 0 here. This is another limit part. Or maybe, let me show you what I'm going to do here. So what I'm going to do, I'm going to separate them. Limit x approaches 0, sine x over x. So you will understand. Once you understand, you don't have to like do all of this thing. You just do it in directly substitution. There. So this whole thing is equal 1 times, when I plug in direct substitution, I do 0. So it's going to give me 0. So 1 over negative 1 is going to give me negative 1. Negative 1 times positive 1 is going to give me negative 1. Done. Question number 6. Let's do question number 6. Okay. And I'm using a different color. 5x plus sine x. Oh, do you see single denominator? It's just clicked in my head when I saw the single denominator. I can do, to be very safe, I'm going to do direct substitution. If I plug in 0, 5, 0 plus sine 0, right, over 0. I know everything is 0 over 0 because we have been checking sine 0 is equal 0 right there. Sine 0, sine is a y value and it's 0. So 0 over 0, I'm splitting the split the question because I have single denominator right there. So I got 5x over x plus sine 3x over x. If you guys see this portion look familiar, I just needed 3 in the bottom and this is equal to 1, right? So I'm going to separate them. I'm going to separate in taking limits. X approaches 0, 5x over x plus limit, like this limit is distributing. I mean, just pretend like that. Sine 3x over x. Okay, this one cancel. So limit x approaches 0, 5. When limit approaches anything to the constant, it's going to be a constant answer. So it's just 5 plus this portion. I have to multiply 3 top and bottom because I have to have a same denominator like the argument. So this portion is going to be equal 1. So I got 3 times 1 times 1. So 5 plus 3 is going to give me 5, 6, 7, 8. So the answer is 8. Let's do question number 7 now. If you guys closely pay attention to this, I do know that, for example, if I have, if I get rid of 6, right, then I have sine 2x by x. And this will give me a familiar special trig, which means it's equal to 1, but I have to multiply 2 top and bottom. So let's remove this 6. And this is not just a 6, it's 1 over 6. You can tell this is in the denominator. So 1/6. Limit x approaches 0. I got sine 2x over x. Now I have to multiply 2 top and bottom. So this whole thing is equal 1. We know that. I'm going to keep my 1/6. And this whole thing is 1. And times 2. That 2 stays. And this is 1. Times 1. So that will be 2 over 6, which will give me 1/3. Okay, let's do question number 8. 8 is like the same thing. If I can get rid of this 2/3. I'm going to move that 2/3. Then I'm left with sine 4x over x, and I can multiply 4 top and bottom. So I have limit x approaches 0, sine 4x over x. Now I'm going to multiply 4 top and bottom. So this portion is equal 1. So I got 2/3. This whole thing is times, that 4 is going to stay, and this whole thing is times 1. So 4 times 2 is 8, and 3 in the denominator, and we are good to go. Okay, we have 9, 10, 11, 12. Okay, we have 14 questions. I didn't know that. Okay, let me move my unit circle again. We're gonna move this around. Okay, let's try question number 9. Now for question number 9, if you guys closely pay attention, the tangent is not in the unit circle, so I have to use identity no matter what. That's the thing, I have to use identity. So I'm gonna go limit theta approaches 0, cosine theta is gonna stay as it is, but this tangent identity is sine theta over cosine theta. That's the identity. So I'm gonna use that identity, sine theta over cosine theta over 3 theta. Okay, what else I can do here? You know, cosine cancel out. I can do that. So limit theta approaches 0, sine theta over 3 theta. Now, you guys do understand I cannot do anything with the argument. This is my argument with the trig. Cannot do anything. I can change it. But if I can move this 3 to the other side, then probably sine theta over theta, my argument and my denominator would be the same thing. So I'm going to move this 1/3. And remember, it's 1/3 because you can tell 3 is in the denominator. So I got sine theta over theta. So this whole thing is equal 1, and 1/3 times 1 will give me 1/3. Question number 10. If you plug in 0, I am getting 0 over 0. You guys can try this. What else I can do here? I can factor out 3. I know I have a single denominator here, but you guys do understand this is cosine. It's not like a sine, like we have the special trig, like sine theta over theta is equal 1 if we are approaching 0, right? But this is cosine, and the cosine, the special trig was, I'm writing this over and over. The argument and the denominator are exactly the same, and this is equal 0. And this one also has to approach 0. Okay, so I'm trying to get something like this, and I can get it if I can if I can get that 3 as a factor out, like I can factor out this 3. 1 minus cosine theta. You see that? Theta. So this whole thing, and limit approaches 0 is equal 0. And 3 is going to stay as a 3 times 0 is going to give me 0. So the answer is 0. Let's try question number 11. Cotangent, I don't have this in unit circle. I can do it, so I have to use identity, and the cotangent identity is cosine theta over sine theta, like it's the reciprocal of tangent. So I'm gonna go and change or rewrite the question. Limit theta approaches pi over 2. Cosine theta is gonna stay, and this is my original fraction. Cotangent, I'm going to write cotangent in a different color. Cotangent identity is cosine theta over sine theta, right? I'm going to rewrite this one more time because I have 2 fractions, right? So I have limit theta approaches pi over 2 cosine theta times this fraction turns to time, and I'm going to do the reciprocal of that. So it's going to give me sine theta over cosine theta. Now I'm good. Cosine cancel. I'm left with sine theta. So what is sine? If I plug in pi over 2, so sine pi over 2. Pi over 2 is right here. Let me move this. I'm going to move this here. So pi over 2 is right here, and this is sine. Sine means the y value, so it's 1. So the answer is 1. Okay, let's try 1 minus tangent theta sine theta cosine theta. Okay, tangent again, we if we plug in 0 there, like a direct substitution thing, so let's plug in 0. 1 minus tangent means I don't have a tangent in the unit circle, so I'm gonna do sine over sine theta over cosine theta over sine theta minus cosine theta. So I'm going to plug in 0 first. 1 minus sine 0 over cosine 0. In the bottom, again, that's my big fraction. Sine 0 minus cosine 0. So what is sine 0? This is 0, sine means 0, right? So I'm going to get 1 minus that 1. Sine 0 was 0. Cosine 0 is 1 in the bottom. Sine 0 is again 0. Cosine 0 is 1. Okay, so this 0 over 1 means 0. We know that. So 1 minus 0 over 0 minus 1. So I'm getting negative 1 actually, the answer. Right? So from the direct substitution, all I did is change this tangent to sine over cosine, and I did the direct substitution because I had to get that 0 over 0, and then you will see you get the answer. If you can get the answer, fine. So you don't have to do anything else. Let's do question number 13 and 14. Question number 13, I can see limit c approaches 3c cubed minus 27 over c minus 3. So I'm going to do direct substitution first. If I substitute 3 for c, then this is what I'm getting. 3 minus 3 is equal, 3 times 3 times 3 is 27. 27 subtract 27 is 0, 0, 0. So I need to factor, I need more work, which means I have to factor out or expand or conjugate, but it's not a square root, so I can do conjugate. It's not a trick that I can use identity. Least common denominator is just one fraction, so I can do that. Okay, so let's factor out. I think that's a good option. And when you see c cube, then it means I gave you guys this before in one of the videos that I said memorize it, and I'm going to give you one more time up here. This is something like that. If you have cubic function, then you have a plus b, a cube plus b cube. Then you can factor this out as a plus b. The first factor is going to be exactly the same sign. If this is plus, then that is going to be plus. Next, I have a squared, and this sign now is going to be subtract ab opposite on b squared. Next one I have is a cube minus b cube. Then again, a minus b is going to stay the same. This sign is going to stay exactly the same. The next one is going to be opposite. If this is negative, then that's positive. ab plus b squared. So just remember this. Now, this one is minus, so I can rewrite it like c cube minus 27, like a cube minus b cube. And how would I do that? It's going to go limit c approaches 3, c cube minus 3 cube, because 3 times 3 times 3 means 27. So this is what it's going to give me, c minus 3. Now I can factor this out, because even if we already know it's 0 over 0, I just rewrote it. Then I have to factor out this, and I'm going to factor out c minus 3, like the first one as it is, like that. Then we have a squared, which means c squared. This is a, that's a b, plus ab, which means 3c, plus 9, which is 3 times 3 is 9, right? B squared, b was 3, so it's 9. In the bottom, I have c minus 3, and I can tell they cancel out. I'm left with limit c approaches 3, c squared plus 3c plus 9 equal, plug in 3, so 3 squared plus 3 times 3 plus 9 is going to give me 27 when you add them. So that was the answer for that. Let's do this one. This is also cubic, so I'm going to apply the same a square and b square thing. a cube minus b cube. I can say this whole thing is a and this is b. Okay, so I'm gonna rewrite this like a cube minus b cube. So it's gonna go ax plus 3, this is my a, minus b cube. I'm gonna find a number that can multiply 3 times and give me 8, which is 2. So this is my a, that's my b, right? I'm gonna put it in parentheses. Now I'm gonna factor out like the way it is a square. So you know a is this portion, right? X plus 3. So I'm gonna write x plus 3 squared. Then I have a plus sign. I'm gonna go plus. Do you see? It's really easy if you know this and write it down on a scratch paper. So this is what it is. Plus a. What is a? X plus 3 is my a. And what is b? B is my 2. So I'm gonna go 2x plus 3 or x plus 3, 2, it doesn't matter, plus b squared. B is my 2, right? Okay, let me do a different color here. This whole thing is a, this one is b, right? So plus 4, b means 2 squared is 4. So this is what I got, and in the bottom I know it's x plus 1. Okay, so let's solve all of this. Oh, this is not supposed to be like that. Okay, this one's supposed to be x plus 3 cube minus 2 cube, and then we get this. Okay, this one is not supposed to be here. I'm sorry, I was doing something, I was writing this down, but this is what it is. Okay, this is, I rewrote this question like that, right? And then this is what I'm getting right now, this portion. So a minus b, and this is a squared, this is plus ab, and that's plus b squared. Okay, so let's try. Now we're gonna go back and solve this. I know it's gonna give me x plus x minus 1, I think. No, x plus 1, because 3 is bigger number. So plus 1. Okay, so x plus 1 right there. And then I have the stuff, whatever the stuff was inside, a square plus ab and plus b square stays inside. Then we have x plus 1. They cancel out, and I'm left with that, which is limit. I'm going to write that limit x approaches -1, by the way. Now plug in -1 in here. So I'm going to plug in that -1 up here, whatever is left. So -1 plus 3 whole squared to -1 plus 3 plus 4. And when you solve this, it's going to give me 12. So my answer is 12. Guys, this is really important that you memorize this, because your AP calculus test is a timed test. So you don't have that much time to do all that stuff. Like you cannot have like x plus 3, x plus 3, x plus 3 and FOIL it. So it means if you memorize all of this, these are the shortcuts that it will help you. And always write like I'm doing it, like this is a, okay, so this is b. Then I rewrote it like a cube and b cube, and then I solved further, and I was looking back and forth to this, and I was plugging in my stuff. What is my a and what is my b? Please, if you don't understand, comment below. I will help you out. And also comment below that how you did on the homework once you checked my answers. Like, share, and subscribe. Thank you.